Welcome back to Prep Forge. Today we cover a classic gang of 4 design pattern that's both simple and everywhere in real frameworks. The template method pattern. Here's the one-line pitch. The template method defines the skeleton of an algorithm in a base class, but lets subclasses fill in specific steps without changing the algorithm's overall structure. It's how you eliminate duplicated logic when several classes do almost the same thing, differing only in a few steps. In this video, we'll build it up with the classic example, making a hot beverage, and cover primitive operations, hooks, the Hollywood principle, and how it differs from the strategy pattern. Let's get started. Let's start with the problem. Imagine you're writing code to prepare 2 hot drinks, tea and coffee. Look at the steps. To make tea, you boil water, steep the tea bag, pour it in a cup, and add lemon. To make coffee, you boil water, brew the coffee grounds, pour it in a cup, and add sugar and milk. Notice something? The 2 recipes are almost identical. Boil water and pour in a cup. Those steps are exactly the same. If you write 2 separate classes, you duplicate that shared logic, and the overall recipe, the sequence of steps, is copy-pasted in both. Duplication like this is a bug waiting to happen. Change the process in one place, forget the other, and they drift apart. We want to capture the common recipe once and vary only the parts that actually differ. Concept 1. What the template method pattern is. The template method pattern solves this with inheritance. You put the shared algorithm, the overall recipe, into a method in a base class. That method is called the template method. It defines the fixed sequence of steps. But for the steps that vary between subclasses, the template method doesn't implement them itself. It calls out to methods that subclasses provide. So the base class owns the structure, the what and the order, and subclasses own the specific details, the how. The skeleton lives in one place, forever consistent, and the variation lives in the subclasses. Concept 2. The template method itself. Let's be precise about the template method itself. It's a single method in the base class that lays out the algorithm as a series of step calls in order. Crucially, it should not be overridable. In languages like Java, you mark it final, so subclasses cannot change the sequence. They can only fill in the individual steps. This is the guarantee the pattern gives you. The order of operations is fixed and defined once, and no subclass can accidentally reorder or skip a step. The template method is the backbone that holds the whole algorithm together. Concept 3. Primitive operations. The steps that subclasses must provide are called primitive operations. In the base class, these are declared abstract. They have no implementation, just a name. Because they're abstract, every concrete subclass is forced to implement them. In our beverage example, brew and add condiments are primitive operations. Tea and coffee each supply their own version. Meanwhile, the steps that are the same for everyone, boil water and pour in cup, are implemented once in the base class and simply inherited. So the base class mixes 2 kinds of steps: concrete shared steps and abstract steps the subclass fills in. Concept 4. Hooks. There's a third, optional kind of step, called a hook. A hook is a method in the base class with a default implementation, often empty, that a subclass may override, but doesn't have to. Hooks lets subclasses optionally influence the algorithm at certain points. For example, a hook called customer wants condiments could return true by default, and the template method only adds condiments if that hook returns true. A subclass could override it to ask the user, or to skip condiments entirely. Abstract primitive operations must be implemented. Hooks are optional. Together they give you exactly the right amount of flexibility. Concept 5. Let's put it all together with the beverage example. Let's put it all together with the beverage. The base class, call it CaffeineBeverage, has the template method, prepare recipe. It runs 4 steps in order: boil water, brew, pour in cup, and add condiments. Boil water and pour in cup are concrete, shared by all drinks. Brew and add condiments are abstract, the primitive operations. Now tea and coffee each extend the base class and implement just those 2. Tea brews by steeping the bag and adds lemon. Coffee brews the grounds and adds sugar and milk. Neither one touches the overall recipe. You've captured the shared sequence once and varied only what truly differs. That's the whole pattern. Concept 6. What it looks like in code. Here's the shape in Java. An abstract base class defines a final method, prepare recipe, that calls the steps in order. It provides concrete methods for the shared steps and declares the varying steps as abstract methods. Then each subclass extends it and implements only the abstract methods. To use it, you create a tea or a coffee and call prepare recipe. The base class's template method drives the whole sequence, calling down into your subclass for the specific steps. Notice you never call the individual steps yourself. You call the template method, and it orchestrates everything. Concept 7. Inversion of Control and a Principal Interviewer's Law. In the template method pattern, the base class is in control. It calls the subclasses methods, not the other way around. The subclass never calls up into the framework. The framework calls down into the subclass. This is called inversion of control, and it's summed up by the Hollywood principle: don't call us, we'll call you. This is exactly how real frameworks work. You fill in specific methods, and the framework decides when to call them. If you understand template method, you understand how nearly every framework is built. Concept 8. A very common interview question: template method versus strategy. They both let you vary part of an algorithm, but the mechanism is opposite. Template method uses inheritance. The algorithm lies in a base class, and you vary steps by subclassing at compile time. Strategy uses composition. The algorithm, or part of it, is a separate object you plug in, and you can swap it at runtime. So, template method: one fixed skeleton, variation by subclassing. Strategy: an interchangeable behavior, variation by swapping an object. Rule of thumb: if the overall structure is fixed and only steps vary, template method. If you need to swap the whole behavior dynamically, strategy. Concept 9. When to use the template method. So, when should you reach for template method? Use it when you have several classes that follow the same overall algorithm but differ in a few specific steps, and you want to eliminate the duplicated structure. Use it when you're building a framework and want to let others customize certain steps while you keep control of the sequence. Be a little cautious of one thing: it relies on inheritance, which is more rigid than composition. So deep hierarchies can get hard to follow. Said simply, the template method puts the fixed steps of an algorithm in a base class and lets subclasses fill in the blanks. Explain the tea and coffee example and the Hollywood principle, and you've shown you truly understand it. And that's the template method pattern. End-to-end. A skeleton algorithm defined once in a base class with the varying steps left as primitive operations for subclasses to fill in, optional hooks for extra flexibility, and the base class firmly in control, calling down into the subclasses. Don't call us, we'll call you. It's how you kill duplication when many things do almost the same thing, and it's the beating heart of nearly every framework you'll ever use. Explain tea versus coffee, and template method versus strategy, and any interviewer will see you get it. If this helped, subscribe for more. Thanks for watching, and good luck in your interview.